invite Tilak Dutta to the stage to present for the technology team.
Thanks, Elizabeth. So I want to talk about superheroes. Why do we love superheroes? I think it's because superheroes have the tools to solve the problems that they're faced with. I think that's why we read Spider-Man comics and go to Batman movies. And I think we're attracted to the idea of a superhero because that's what we want to be able to do too. We want to be able to solve our own problems with the ease that Iron Man can deal with his problems. In particular, we tend to run into more of these sorts of problems as we get older. Nearly all of us will either have a disability ourselves at some point in our lives or care for someone that has a disability at some point in our lives. Unfortunately, many of the tools that we'll need to deal with these problems don't exist yet. And that's where our team, the technology team, comes in. We use our clinical and technical knowledge to design, evaluate, and commercialize tools that help us solve problems that help us get through our lives. These tools keep us happier and healthier, living in our own homes longer. Today, we wanted to give you a taste of some of the projects that we're working on. We're going to take you through some of the challenges that a typical older adult, Clint, and his caregiver, Dorothy, face, and how we can help to make them feel like superheroes by giving them the tools that they need. We begin with Clint as he tries to get out of bed in the morning. Clint has trouble standing. Dan has a solution to increase Clint's mobility.
So the sit-to-stand transfer is an important precursor to many activities of daily living, including toileting and meal preparation. Standing up, or older adults are often living in the home with disability who are unable to stand up. The transfer pole is an important piece of assistive technology that enables these individuals to stand up where they would otherwise be unable to do so unassisted. My project's focused on using biomechanical modeling to develop an evidence base to determine which type of configuration of this pole, be it a single pole, two vertical poles, or a pole with a horizontal bar, or where should the pole be located? So should it be close to the individual or maybe a little bit further out? I'm here to develop an evidence base to determine which is most effective at reducing effort and improving stability throughout the sit-to-stand movement. We'd like to take this evidence to gain a better understanding of the assisted sit-to-stand movement and then work towards developing firm recommendations as to which configuration and what installation locations are ideal.
Dan, it looks like Clint could use a hand.
Allow me to help you, friend.
Congratulations, Clint. You level up. You've earned a set of power gloves. Once Clint is out of bed, he's still unsteady on his feet and usually hangs on to Dorothy to get around. Vicky has an idea to help Clint be more effective.
So Clint now faces the challenging task of getting to the bathroom, but unfortunately he just doesn't feel that stable with a walker. They tried to install handrails, but for some reason the landlord vetoed the idea of drilling into their walls. So what do? This is a problem that many people with mobility deficits face every day as they try to engage in basic activities of daily living. To provide a safer alternative, we're developing a set of pressure-fit grapples and horizontal handrails that you can clip on within the home. These can be configured along your corridors, inside your rooms, to provide safer support for walking and to help Clint move around more easily. The pressure-fit installation is easy and does not permanently modify the home. We are working with therapists, caregivers, manufacturers, and engineers to develop this product, which we expect to launch commercially early in 2013. And since I have a moment, go Stamps.
Congratulations, Dorothy. You've earned a set of hands-free power gloves. Now Clint needs to go to the toilet and take a bath. But usually he needs Dorothy's help. And without better tools, there's a good chance that Dorothy will get hurt. Emily and Roa are working to understand this problem so they can find a solution for Dorothy.
Even with the assistive devices he got after a visit to an OT, there's still a lot of help that Clint needs from his caregiver. To sit down, get up again, clean himself, take a bath, and so on. But the bathroom is a really tight space. So how's Dorothy supposed to help him? Even the professional caregivers can't always use the techniques that they were taught in school. There's just not enough space. So they improvise and do their best to provide the care that's needed by their client. But they know that this isn't always the safest, and the bathroom is one of the places that these two people are most likely to get hurt. So how do caregivers actually provide care? What do their improvised techniques look like? And what are the riskiest parts of them? That's what I've been looking at in the bathroom of Home Lab at Toronto Rehab. And with the answers to these questions, we hope to devise safer ways to get Clint and Dorothy through this part of their morning.
Not to worry, we're already working on developing a solution. But first, we need to understand the techniques that caregivers are using to overcome these challenges in such difficult space. Since current motion capture systems are too large to fit in a setting such as the bathroom, and the current biomechanics evaluation tools require extensive time and effort to process the data, we're developing a system that will address these two issues and allow us to collect realistic data in a bathroom setting. The system that we're developing uses multiple Kinect sensors that will track the caregiver's joints to identify common postures and estimate the associated spinal loads. And it also will allow us to evaluate other parameters that will be used to compose design specifications for a system that we plan to develop that will address back injuries in the home setting.
Congratulations, you've both earned utility belts. Just pass it on. Thanks. Next, Clint and Dorothy head downstairs for breakfast. Allison describes how she plans to make stairs safer.
What a hazardous location in our homes. If only those stairs were safer for poor Dorothy and Clint. Currently, the National Building Code permits steps that are just too high and too short. These building standards lead to a very high risk of falls, which result in serious injury and death. Now, many strategies have been proposed to address falls on stairs. However, to have the greatest impact at a societal level, we think that changing the building standards are the most effective, because risk factors such as step dimensions can be corrected and do not require modifications in the person's behavior or physical function. Our work, which is currently underway, is using laboratory-derived biomechanical measures to provide the necessary empirical evidence to support a change in our building codes and make stairs safer for everyone.
Congratulations! You've earned a safer staircase. Once Clint finishes with breakfast, he finds he has trouble getting out of his chair. Regina offers a solution.
It appears like Clint is trying to use his armrest to help him out of his chair, but the armrests don't seem to be adjusted properly to help him get up. Studies have shown that armrests aid the sit-to-stand motion, but no one has looked at the optimal armrest variables, such as armrest height, width, depth, and angle. I'm currently studying to find the optimal armrest variables to help the sit-to-stand motion. Let me try to help Clint. Hi, Clint. You seem to be having a lot of difficulty getting up with the armrest adjusted like that. Let me try to help you. This should be much better now.
Congratulations, you've earned a power mask. Now Clint and Dorothy need to make a trip to the grocery store, but neither is able to drive. Dorothy's doctor recently told her she can't drive anymore. She admits she has trouble driving at night, but feels that she should be fine driving during the day. Robert has an idea that may help.
So as we age, driving becomes more challenging, and the risk of having a fatal accident increases substantially. By 2031, Canada will be home to 9,136,000 drivers over the age of 65, and we want to find ways to assess and train them both safely and effectively. Now, driving simulators are an excellent way to test people under challenging conditions without endangering them, but problems with simulator realism can contribute to discomfort and nausea, ultimately alienating older adults from research. So what we would like to do is to use Toronto Rehab's state-of-the-art driving simulator to better understand how sight, sound, motion, and vibration come together to create the experience of driving. And this will allow us to improve simulator realism, to get older adults involved in research and training, and to keep them driving safely for as long as possible.
Congratulations. You've earned a giant novelty driver's license on improving your independence. Now, until Robert's training and testing system is implemented, Clint and Dorothy have to find other ways to get around. Mobility in the winter is particularly challenging due to its icy conditions. Our winter team is looking at a number of these problems. First up is Varun to talk about his work.
So, wheeled mobility aids, particularly electric scooters, are growing in popularity in recent years, especially among older adults like Clint who can no longer drive. Almost 100,000 Canadians actually use these devices regularly for various activities like going to the doctor or just going grocery shopping. Unfortunately, the technical standards for these devices don't mandate any sort of winter testing. So if you look in the instruction manual, it'll simply tell you not to use your device in rain or snow or any sort of inclement weather conditions. Unfortunately, for people like Clint who rely on their devices every day, that's often not an option. So what I'm looking to do as part of my project is kickstart the development of a new more rigorous winter test method for scooters using the Winter Lab at Toronto Rehab, and in doing so eventually improve the safety and usability of these devices. So eventually your scooter will be approved for winter use.
Congratulations, you've earned a scooter and improved your mobility. Now it's Dorothy that's having trouble keeping up on the ice and snow. Jen has some suggestions for better footwear for Dorothy.
Dorothy thought that she was all set for the winter. She bought a whole brand new pair of winter boots that were labeled slip resistant, but she's still slipping and sliding, and she's really afraid that she's going to fall and hurt herself. This isn't an unfounded worry because over 7,000 Canadians are hospitalized each year due to slips and falls on ice and snow. We're trying to help Dorothy and all other pedestrians by improving the tests that are used to assess winter footwear slip resistance. What we found in our experiments are that sliding speed and foot angle that are used in testing are very, very different from the actual parameters when we measure gait characteristics while walking on actual ice. And we'll use this information to make sure that future boots, which are labeled slip resistant, are really slip resistant.
Congratulations on earning the seal of approval on your new footwear. Kathleen has been studying how spikes can be added to footwear to make them even better on snow and ice.
Falls on ice are a serious concern for anybody, but particularly for older adults like Dorothy and Clint, because it can result in a loss of independence, not just because of injuries sustained, but also because of a fear of falling and of going outdoors in wintertime. Unfortunately, much of current footwear soling has been shown to be very poor in terms of slip resistance from biomechanical tests, and anti-slip devices also have many shortcomings. There hasn't been much research into how these devices should actually be designed, so we're looking at different characteristics like spike position and spike height and how those impact slipping and tripping, so that we can start to develop basic guidelines for how these devices should be designed and developed. And at the end of the day, we're hoping that we can provide pedestrians with the ability to safely and confidently walk outdoors in wintertime.
Congratulations. By making use of the tools developed by the technology team, Clint, you have been transformed into a superhero, and Dorothy, you are now his trusty sidekick. We think many people who deal with problems like the ones faced by Clint and Dorothy could benefit from the tools we're developing. So it's important for us to get this message out, and this is what Dawn is working on.
Hi, my name is Don Phillip. I'm with the University of Toronto's Mississauga campus. My undergrad students and I have been working on science outreach for IDAPT, doing three things that are a bit unique. The first is that we've been presenting at conferences and other venues, such as the Science Teachers Association of Ontario Conference, and we even managed to get an article published in their magazine last September. The second thing we're doing is to create classroom materials, lesson materials, that are linked to the Ontario curriculum but feature IDAPT's work. This is so that the teachers can use them in class and not lose class time. We also try to get the students to think like scientists. And the third thing we're doing is to try and get the undergrad students to think like researchers. We treat everything as a design problem. Everything we do is a design problem that they have input into to get them thinking in design mode. Thank you.
We will spread the word.
I'd like to thank all the technology team members, as well as the stars of our performance, Leon and Catherine, playing the roles of Clint and Dorothy.